Hello. So section 5.2 is on the law of cosines. The law of cosines is something we use whenever we have a side, an angle, and a side, like in that order. So two sides and the angle in between them. That setup means we can't use law of sines because we don't have any pair. So this is our other equation that we go to. One of the things to note is the way the triangle is set up here. This is standard. So A is across from alpha, B is across from beta, and C is across from gamma. So that is a little lowercase gamma, not a Y, but kind of ends up looking like a Y. I usually end up writing it kind of like that. Okay. So here's a classic setup. You have two side lengths and the angle in between them. So we're going to have to use law of cosines. Now there's three different forms, but I tend to use this third one because it starts looking just like the Pythagorean theorem, and then I just add on this little extra thing. So do pay attention to, there's an A here and here, B here, B here, C over here, and gamma over here. I'm pointing this out because you need to make sure that where you put the things corresponds correctly. In the regular Pythagorean theorem, C is the hypotenuse, which is the side across from the 90-degree angle. Some of you guys messed that up on the test. So in this one, though, it can be any, as long as we've got all but one of the variables here, we can solve. Typically, though, we're going to solve for gamma or C. We usually know A and B. So don't try to use one of the other two forms. Like they work, but typically, like that's the one we'll go with. Okay. So even though they called it beta here, whatever. All right, so I've got, let's see. Okay. So if we use the B form, we'd have B squared equals A squared plus C squared minus 2AC, because it's always the same ones from that side. And we call it the law of cosines, so it's a cosine. And then the angle that matches the thing way on the other side. And now we are just going to fill in the things we know. So we don't know B. So A is 10. C is 12. And our angle for beta is 30 degrees. Now, even though the cosine of 30 degrees is on the unit circle, we don't care because we got a whole bunch of other stuff to add to it. And then we're going to have to square root it. So we don't try to get the exact answer on these. We're just going to go for whatever the decimal approximation is. So all of that stuff on the right there, I'm going to type it all on the calculator. That's taken care of. So now we can use law of sines to find one of the other angles. And then it's just all three angles have to add to 180. So we'll do that to find the third one. But this whole take the given information and be able to tell me the other three pieces of information about the triangle, it's a very standard question format. You're going to have to do it. Hint, hint, nudge, nudge, wink, wink. All right, so we have beta and B. I'm going to go with A. So gamma is 180 minus 30 and minus the one we just found. On our next one, we have to draw the triangle. Oh. All right. Okay, got that, but I rounded, whatever. Right, so we got A, we got beta, so now we can get gamma. 180 minus 30 minus 23 points, blah, blah, blah. Okay, I got A is about 14 point something. That's across from the 30 degree. My beta is 23 something. And then my gamma angle is pretty big. It's 126.21 whatever. 24 is very much bigger than 12 and 14, so it should have a very much bigger angle. B is the smaller side, so beta should be smaller than alpha. 14 is only a little bit more than 12, so the 30 degrees is only a little bit more than the 23.79. So it's a good idea just once you get your final numbers, put them back in and make sure they make sense. Smallest angle gets the smallest side. Largest angle gets the largest side. All right, I'm gonna cut it there.